atoms. What are atoms? Atoms are the individual units packed in a repeating fashion. Okay, there are certain elements which doesn't want to combine with another element, and these elements are called as noble gases. Say for example, if you take helium or neon or argon, they don't want to combine with another element. Okay, they will exist just by themselves. Okay, so here are some examples for elements which can exist as noble gases. They are going to occur as a single atom. Okay, whereas there are certain elements which doesn't want to exist by themselves. Okay, they wanted to combine with another atom of themselves. Okay, so if you take hydrogen, hydrogen doesn't want to stay by itself. Instead, it wants to combine with another hydrogen, forming a hydrogen molecule. So this is called as a diatomic molecule. Okay, not only hydrogen, but there are also other elements which does exactly the same thing. For example, if you take oxygen, oxygen doesn't want to stay by itself. It wants to combine with another oxygen, forming oxygen molecule, diatomic oxygen molecule. And similarly, nitrogen. Nitrogen doesn't want to exist by itself, and therefore it wants to combine with another nitrogen, forming nitrogen diatomic molecule. Okay, so if you want to look at a representation of how they are going to exist, this picture is going to give an idea about their representation. So a noble gas wants to exist, like the noble elements wants to exist by themselves. They don't want to combine with any other atom. Okay, whereas the diatomic molecule, you can see that there are two atoms. They are combined with each other to form the diatomic molecule. Okay, so this is a representation of the noble gases and the diatomic molecules. Now, what is a molecule? Molecule is an electrically neutral particle composed of two or more atoms chemically combined. If the atoms are that same element, then the molecule is called an element. So this is exactly the same thing that we have talked in the previous slide. But what's going to happen if the elements are different? They have a special name which is called as compound. Okay, suppose if you take water molecule. So in water molecule, every oxygen is having two hydrogens. Okay, so they are actually different element. If you take hydrogen, hydrogen is a different element than oxygen. So it has to be called as a compound. Similarly, if you take ammonia, for every nitrogen, there are three hydrogens. Obviously, the nitrogen atom is different from hydrogen atom. So these are called as compounds. Okay, so this is the way that we represent the molecules. Molecules can be represented either by a ball and stick model. So here is the ball and stick model. And here is the space filling model. So in the ball and stick model, the atom is actually represented as a circle, and the electrons between them, or the bond that exists between them, is represented by a stick. Okay, and in the space filling model, electrons are considered as a cloud. So therefore, both of the atoms are considered as a circle here. Okay, now if you take hydrogen, we know that there is only one bond between the two hydrogens. So therefore, each atom is actually, the two atoms are connected together by a single bond. Okay, if you take water molecule, there are actually two bonds. There is a bond between oxygen and hydrogen. There is another bond between oxygen and another hydrogens. Okay. Okay, and this is the structure for ammonia, where there are three bonds, and this is the structure for methane, where there are four bonds that comes out of carbon. Okay. Okay, there are 7 common elements that exist as diatomic molecules. Okay, number 1 would be hydrogen. Next would be nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And all of these right here are said to be halogens. And usually when writing the formula for these elements, you always write it as a diatomic molecule. Say, for example, you cannot write the equation as H plus Cl gives HCl. Okay, this is entirely wrong. You will use it as H2 plus Cl2 gives 2HCl, because you always needed to represent the diatomic molecule as either an H2 or Cl2 or N2 or an O2. Okay, now let's go on to allotropes. What is an allotrope? Two or more forms of the same element that have different bonding structures in the same physical phase are called as allotrope. Suppose if you take carbon, can exist in two different allotropic forms, or actually more allotropic forms. Okay, one example would be diamond, another one would be graphite, but there are also nanocarbons. There is Buckminster fullerene and all those structures available for carbon which exist as allotropes. Both pure diamond and pure graphite are actually 100% carbon, and both are solid. But what distinguishes between these two structures is their atomic arrangement of the carbon atoms. Okay, so let's look that in the next line. Okay, so here are the three main allotropes of carbon, but there are also other allotropes of carbon. Okay, so now we have nanotubes, and there are different versions of the nanotubes. Okay, so here is diamond. When you look into diamond, let's say that this is carbon. This is the first carbon. The first carbon is actually connected to 4 different carbons, which is giving a tetrahedral arrangement. Okay, but that's not the kind of arrangement that happens in graphite. Okay, so you have different layers, but the bonding between the different layers are actually weak. And we also have the buckyball, which is also called as the Buckminster fullerene. Okay, so the type of bonding that exists in all of these different forms of carbon are going to be different. But we know that diamond is going to be the hardest part that comes because of the tetrahedral arrangement of the atoms. Okay, not only carbon, oxygen can also have allotropic forms. Oxygen can exist in 2 different allotropic forms. The first one is oxygen gas, and the second one is oxygen O3, which is also called as ozone.